Alo, alo. Ờ, lớp CC02 của mình là cái buổi học gần nhất của mình là trước khi mà nghỉ lễ đúng không? Nghỉ 4 tuần đúng không em? Là lần trước là mình học xong hết chương số 4. À, hết chương số 4 đúng không? Hết chương số 4 khoảng canh cậy đúng không? Các bạn xác nhận giúp cô xem.
Dạ đúng rồi cô.
Là lần trước mình hết chương số 4. Ok, vậy hôm nay mình sẽ bước sang chương số 5. Okay, good afternoon everyone. We have I just have checked with you about what we have done before the holiday. So we have done together chapter 4. Chapter 4 is about the confidence interval. The most important in chapter 4 is the confidence interval. But in chapter 4, we also know some. We also learn together some fundamental concept of our statistic. Okay. For example, you should identify the the population mean. You just difference between the population mean and the sample mean. The population standard deviation and the sample standard deviation. And we know some important point estimator. Okay. Okay. Anyway, let's move to chapter 5. Chapter 5 is about hypothesis testing. So first of all, I'd like you to focus on example 1. Okay. I left you a few seconds for your reading. Okay. Just 10 seconds for your reading example 1. Okay. Okay. Example 1. Suppose that an engineer is designing an aero escape system that consists of an ejection seat and a rocket motor that powers the seat. The rocket motor contains a propellant, and for the ejection seat to function properly, the propellant should have the mean burning rate of 50 centimeters per second. If the burning rate is too low, the ejection seat may not function properly, leading to an unsafe ejection and possible injury of the pilot. Higher burning rate may imply instability in the propellant or an ejection seat that is too powerful. again leading to possible pilot injury. Okay. So example one show us a technical issue. The technical issue required the system must have the mean bending range of 50 centimeters per second. We know that if the mean bending range of the system of the repellent is less than 50 centimeters or greater than centimeter, it still leads to possible injury of the pilots. Okay. So suppose that the engineers already invented this system. They already produced the system. So how could they check whether the mean bending range really equals to 50 centimeters or not? Okay. How could they check whether the mean bending range equals to 50 centimeters or not? This is the um, the technical questions. So if they want to make conclusions about the mean bending range, of course they need to have the data, right? So how could they have the data? Of course they need to conduct the experiments. For example, suppose that the engineers conducted 10 trials. It means that they repeat the experiments in 10 times. And each time they measure the mean, in each time they measure the burning rate of the propellant. Suppose that the first time they record the burning rate of the propellant equals to 50.1 centimeter. Okay. And the second time, suppose that they record 50.3 centimeter and 4.9 per 4 or 49.2 centimeter. Okay. And now the question is that basing on the experimental data, basing on the given data, how could they can answer for the questions whether the mean bending range of propellant different to 50 centimeter or not, or it can be greater than 50 centimeter or not, or it can be less than 50 centimeter. Okay. So maybe some of you may wondering that, okay, if we already have the data, this is the burning range. This is the burning range recorded at each trials. So if we already have the data, so why don't we calculate the average? Consider the average of those values. Because here we care about the mean burning rate of the propellant. So you remember that, okay, the mean means not the average values, right? The mean burning rate is the average burning rate of the propellant. To know whether it's equals to 50 centimeter or not, we already given the data. So some of you may wondering, okay, why don't we take the average between them? Right? Taking the average, suppose that you have the average equals to 50 centimeter per second. You see that, okay, it's exactly 50 centimeter per second. So we confirm that the mean burning rate of the propellant equals to 50 centimeter per second. No, it's wrong. Why? Because remember that in the questions, does the data give enough evidence to confirm that the mean burning rate of the propellant equals to 50 centimeter or not? In these questions, we're talking about the mean burning rate. So the mean here is the population mean. The population mean. It means that the true mean of burning rate, the true mean burning rate of the propellant of the system. And we may never observe. We don't know. We may never know. What we know is just the burning rate, the observed burning rate. It means that each time you repeat the experiment and you record the burning rate, so you get one value. The second time you get the second values. Even you try to repeat the experiment in 10 times or in 100 times. If you take average of those values, you only have the sample. You only have the sample mean. You only have the sample mean. First in the questions, we want to make the conclusion for the population mean. To make sure that you identify the differences between the sample mean and the population means. Recall that last time in chapter 4. In chapter 4, we said that the populations will be the whole of objects we want to study. So the populations. Usually, the populations will be difficult to observe, or we never observe. Okay? And what we observe is just we have the sample data. We have the sample data. The sample data is just a part of the populations. We observe the sample data. And the true mean of the whole of the populations is the population mean, which is given by parameter mu. And the sample mean from the given data, from the given sample data, we can calculate the average of those values. The average of those values is called the sample mean, as per. The true population parameter is always unknown. Is it unknown? That's the reason why we want to make inference about them. Inference is mean that we construct estimations for parameter mu because we don't know. We don't know, so we want to estimate for this value. Okay, and S bar is observed. Because S bar is just average of those values given in the sample data, so we observe. And we use S bar to estimate for parameter mu. Okay. So now return to our problem. Now, to know whether the mean burning rate of the propellant equals to 50 centimeter or less than 50 centimeter or greater than 50 centimeter, the engineers conduct the experiment, and they have the sample data. Given the sample data, we want to know if, given the sample data, using the information given in the sample data, how could we know whether the mean burning rate equal to 50 centimeter or not? To answer for these questions, of course, we will use information from S bar because S bar is one estimate of mean. Okay, but how to use the information of S bar to answer for the question about the population mean? Okay, and this technique is called the hypothesis testing. We are going to learn in this session. Okay, we are going to learn in this chapter. Okay, now we're always talking about hypothesis testing. So first of all, we need to understand what is the statistical hypothesis, or simply hypothesis. Okay, this is a claim or assertions either about value of a single parameter, about the values of several parameters, or about the form of the entire probability distribution. Okay, so can you see that we have three parts: single parameter, several parameters, and the form of entire probability distribution. Okay, so the statistical hypothesis is just a claim or the statements, the assertions for single parameter. This is exactly the case in example 1. We make the conclusions on the claim that the mean value of burning rate equals to 50 centimeter or not. This is the claim. For the single parameter, the parameter is parameter mu. Okay. Or it can be the claim of several values for several parameters. Okay. And the hypothesis for several parameters we going to learn in chapter 6 and also in chapter 7. Okay. And finally, the claim for the entire probability distribution. So as you have seen that in chapter 4, when we construct a confidence interval, several times we assume that the population is following normal distribution. Remember that the population we don't know. Generally we don't know. So of course, actually we don't know distribution of population. So we assume that the unknown distribution of population is follow normal distribution. Of course, we need to check. We need to check basing on the the data set. Basing on the data set, is it reasonable to assume that the population follow normal distribution or not? This is also hypothesis testing, which is testing about the probability distribution. Okay, but for limited time. During the course, we don't learn about the hypothesis for entire probability distribution. We only focus on hypothesis test for parameters. Okay. Lastly, we define the null hypothesis and alternative hypothesis. The null hypothesis, denoted by H0, is the claim that is initially assumed to be true. Because we want to prove something. Of course, firstly, we need to assume something is true, and then we collect the information to know whether the statement, whether the claim we assume to be true initially, now we should reject it or we won't reject it. Okay? And the alternative hypothesis, H1, is just opposites to H0. That's all. So we have two kinds of hypotheses, H0 and H1. H0 and H1, they are opposites to each other. H0 will be something initially assumed to be true. Okay, assumed to be true. Awesome. And to know whether it's really true or not, we need the data. We need the data. And then we make conclusions. Okay. And H0 or H1 is just opposites to H0. Okay. So the test of hypothesis is a method for using sample data to decide whether the null hypothesis should be rejected. Okay. So on of the whole procedure here. Given the null hypothesis, we assume that it is true. Then using the sample data, we make the conclusions about rejecting or not rejecting H0. This is called the test of hypothesis. Okay. Of course, because we want to test for hypothesis, the first step now is to construct the null hypothesis H0 and the alternative hypothesis H1. Okay. To answer for these questions, let I remind you, the key concept in hypothesis testing is that the hypothesis testing aim to reject H0 basing on the sample data. The whole procedure in hypothesis testing, we collect the information from the sample data to answer for the questions whether we should reject H0 or not. The whole of procedure with the aim, with the purpose, with the goal of rejecting H0. That's the reason why we also said that rejecting H0 is always a strong conclusion. Okay, because it's our aim. Rejecting H0 is our aim. This is this is our final goal. This is the final final purpose. So of course, Rejecting H0 is always a strong conclusion because this is what is our want to do. Because of this reason, and because H0 and H1 they are opposites to each other. So of course we will put the statement about which is important to make strong conclusions into alternative hypothesis. H1 and H0 are opposites, and rejecting H0 is a strong conclusion. Reject H0 is strong conclusion. Reject H0 implies that H1 is true, right? Because H0 and H1 are opposites. So naturally, even though the aim of hypothesis is to reject H0, but because H0 and H1 are opposites, so it's indirectly confirmed about H1. So of course we will put what we want to prove into H1. Okay. And nextly, remember that only make conclusions of rejecting or not on H0. If some one of you construct the hypothesis and at the end you said that, okay, I reject H1, it's wrong. Because the concept of hypothesis is making conclusions on H0, not on H1. Okay? So as I told you, making conclusions on H0 indirectly confirm the conclusions on H1. There are two cases. If the test rejects H0, we confirm that we have enough evidence to confirm H1 is true. So it seems to be very obvious. If H0 is true, if H0 is rejected, H0 is rejected, imply H1 is true. How about the second case? If not rejected, if H0 is not rejected, does this mean that H1 is wrong? H0 is rejected, imply H1 is true. It's okay. But oppositely, if H0 is not rejected, if some one of you confirm that H1 is wrong, then no, it's wrong. No. Because pay attention that we only said that rejecting H0 is always a strong conclusion. Because the whole of procedure, we collect the information to solve for this aim, to support for these conclusions. So how about if we fail to reject H0? If unluckily at the end, we see that we fail to reject H0. So what is the conclusion on H1? Nothing. We don't know. Because the procedure, the whole procedure, we collect information to support for the conclusions of rejecting H0. But unluckily at the end, we fail to reject H0. It means that we don't know. We don't know whether, finally, we don't know whether H1 is true or not. We don't know. It just means that we don't have enough evidence. Evidence here is mean that information. Because the whole of procedure, we didn't collect the information to support for the case of fail to reject H0. We didn't do it. So at the end, if we fail to reject H0, so we just confirm that we don't have enough evidence to confirm that H1 is true. If some one of you said that fail to reject H0, so you confirm that H1 is wrong. So it's totally wrong. Theoretically wrong. Okay? Remember that we don't have enough evidence to confirm H1 is true. Imply that we really don't know whether H1 is true or not. We don't know. That's the reason why we also said that not rejecting H0 is a weak conclusion. A weak conclusion because we don't know. We don't know. Actually, H1 is true or not. We don't know. So this is the weak conclusions. We only have the strong conclusion in case that we reject H0. Rejecting H0, we still have strong evidence to state that, to confirm that H1 is true. But oppositely, this is the weak conclusions. We don't know whether H1 is true or not. Okay. So until now, you should able to write the null hypothesis H0 and alternative hypothesis H1 for the first example. Okay. Now I return to the first example. Okay. Return to the first example. Now let's try to write the null hypothesis and the alternative hypothesis for the given three questions. I will start with question 2 because it's easier. Okay. Okay. Write down the null hypothesis and the alternative hypothesis. The first step, we need to identify which kind of parameters we should use. Okay, which kind of parameter we want to make the test. Okay, in this case, we already know that we want to make the test for the mean learning range, the mean. So we know that the population mean given by the parameters mu. Okay, right, mu. And then put the statements we want to prove into H1. So here we want to prove the mean learning range of propellant is greater than 50 centimeter, greater than. So write down greater than. The constant is 50, so write down 50. And H0 is opposite to H1, so oppositely you write less than or equals to 50. That's all. Easy, right? Continue with question 3. Question 3. We write H0. Here we still care about the mean, so write down the mean is mu. H1, the mean is mu. Put the statement we want to prove into H1. So less than 50 centimeter. So I write less than 50 centimeter. And oppositely, we write greater than 50 centimeter. Okay. How about question 1? Why did I let question 1 at the end? If you continue H0, again we use mu. And then teacher said that put the one we want to prove into H1. So write down. So you write down mu. So you write down mu equals to 50. And oppositely, write down H0, mu different to 50. This is wrong. No. Why? Why the way I write for question 1 is wrong? Okay, I will return to answer for this questions. Now I let question 2, the hypothesis of question 2, to have further discussions. Okay, this is the null hypothesis and alternative hypothesis for question 2 is correct. Okay, and even though opposites to H1, we have H0, mu less than or equals to 50, is corrected. But because the key concept of hypothesis testing, firstly, we assume that H0 is true. If H0 is true, it means that we are assuming mu less than or equals to 50. But just conventionally, convention by convention, we assume that mu equals to the constant. For example, here mu 0. Even though mu can be less than or equal to 50, but we assume that H0 is true, imply that we are assuming mu receive the single constant value. And then we use it for later calculations. It's just conventions. Okay? It's just conventions. So conventionally, we will write. Of course, writing mu less than or equal to 50 is still corrected. Okay, but some of the book, especially during the course, I refer to write mu equals to 50 only. We don't care whether less than 50 or greater than 50. Just always identify the parameter we want to test, the constant we want to compare to the parameter, and then put equal between them. That's all. So you have H0. And for H1, you read the sentence. We compare with the constant greater than, so write down greater than. Less than, so you write down less than. That's all. But remember that always the equal size, the equality always happen in the null hypothesis. H0 never happens in H1. The equality only happens on the null hypothesis. Remember in your mind. It's really key concept of the hypothesis testing. Suppose that if you write for some case, suppose that you write mu greater than 50, and oppositely you write mu less than 50, it will be wrong. Never. The equality, the equal size never happens in H1. Never happen in H1. It's only happen in H0 because we assume that the parameter equals to the constant, and then we use this assumption for later calculations. Okay, so that's the reason why I tell you in question 1, if you write H1 is mu equals to 50, it's totally wrong. Never, the equality never happen in H1. Okay, so return to, okay, clean everything. Now I rewrite the null hypothesis once more time for the given 3 questions. Question 1. Okay, H0. Teacher told us that we just need to identify the parameters we want to use. So the parameter is mu. And put equal to what? The constant given here 50. So write down 50. Don't worry. H1. So we care whether the mean equal to 50 or different to 50. We don't care. It's less than or greater than. So this is two-sided. So write down mu different to 50. Okay. Question 2, once more time. H0. We don't care about the size. Less than or greater than, we don't care. Always write down mu equals to the constant. And then H1, now we care. Greater than or less than. The question is greater than, so write down mu greater than 50. And lastly, number 3, once more time. H0. Write down the parameter equals to the constant. The constant is 50. And then H1, we want to prove it's less than 50, so write down less than 50. That's all. Okay. This is the way how we can write the hypothesis H0 and H1. Okay. Now we said that we have two-sided alternative hypothesis. If H1 is written in form of mu different to the constant, okay, we just care different to the constant. It can be less than or it can be greater than. So that's the reason why we said that we have two-sided. And then one-sided alternative hypothesis, we need mu greater than 50 or mu less than 50. Okay. Now, of course, you may wondering, we already able to write the null hypothesis and the alternative hypothesis. So of course, the next step, we need to know how to construct the hypothesis testing, or equivalent to say, how could we know whether we should reject H0 or not? Okay. To know whether we should reject H0 or not, given the data, remember that the hypothesis testing is the method basing on the sample data. So of course, we need the quantity the quantity calculated from the sample data, such that it can tell us it can tell us the decisions. Okay, and this quantity we call the test statistic. The test statistic generally I denoted by TS. It is just the function of sample data, the functions of sample data, on which the decisions to be based. It means that it can tell us whether we should reject A0 or not. A test statistic is the function of sample data. It means that plug in different sample data, we should have different test statistic values. Okay. And nextly, of course, we need a criteria. We need the rule can tell us should we reject A0 or not. Okay. So okay, so we define the rejection regions. Rejection regions is just the real interval. This is the interval. And this is the collections, the set of all test statistic values for which A0 will be rejected. Okay, so rejected regions indicated by RR is the set of all test statistics where A0 is rejected. And this is the real interval. Okay. And of course, the complement of rejected regions is called the accepted regions. Okay, so rejected regions, the complement of rejected regions equals to the accepted regions. Okay. Now the question is that how could we find the rejected regions? If we know rejected regions, so we can know whether we should reject A0 or not. Because if the test statistic belong to rejected regions, we will reject A0. If the test statistic values calculate here, plug in the data, the test statistic doesn't belong to rejected regions, we won't reject A0. So we will find the rejected regions basing on the equation that given the significant level alpha, the probability of rejecting A0 must exactly equals to alpha. Okay, the probability of the test statistic belong to rejected regions is exactly equal to alpha. Okay, and you can see that looking for the rejection regions equivalent to solve for these equations, and this equation is the probability of the random sample, the test statistic. And to find the probability of the random variables, of course, we need to know distribution of the random variable, right? If we don't know distribution of random variable, how could we find the probability? Hence, looking for rejection regions, we must solve the given equations. Solving the given equations, we need to find the distribution. We need to find distribution of the test statistic. Okay, distributions. Okay, and here I summarize for you the general procedure. The general procedure to construct the hypothesis testing. Of course, the first step, we need to state the null hypothesis and the alternative hypothesis. The next step, find the test statistic values basing on the sample data. Plug in the sample data. We have the test statistic values. And of course, basing on the assumption that A0 is true. Step 3, determine the rejection regions. Basing on distribution of the test statistic, because we need to solve for equations probability of the test statistic belong to rejected regions is exactly equal to alpha. So approach rejected regions depending on distribution of the test statistic. Okay, and finally, make conclusions. If the test statistic values belong to rejected regions, we reject as zero. If it doesn't belong to rejected regions, we confirm that we won't reject as zero. Okay, those are this is the general procedure. So of course now we need to apply into some particular cases to see how could we construct the hypothesis testing in some particular cases. Okay, and similar to confidence interval, we also classify uh, our work into four cases basing on different assumptions. Okay, and I will try to go into detail. I try to go slowly for the case one because case one will be fundamental for all of the other cases. Okay, so I think that before we move to construct the hypothesis testing for the next four cases, I'll let you a few minutes for break because it takes a little bit time for the first case. So I think that better to have the break before we continue. Okay. Now it's three. Okay. We return at 4 p.m. Okay. Around more than 15 minutes for your break, and then we continue. Any questions? Questions? Hoàng Phương Vũ, what's your questions? Tình hình nhóm em sao em?
Dạ, alo cô nghe thấy không ạ?
Rồi em nói đi.
Dạ là cái bạn Nguyễn Hoàng Minh đó của nhóm em là tụi em liên lạc không được cô.
Không được thì kệ bạn đó, em nhóm em cứ làm thôi, thì bạn đó không làm thì em không khai bạn đó vào project thôi.
Dạ, dạ được rồi. Dạ em cảm ơn cô ạ.
Thì ai có làm thì em mới điền tên vào thôi, không có nghĩa là cô giao như thế nào em phải điền tên như vậy. Tên của bạn nào có làm bài mới bỏ vô trong đề tài thôi. Rất là để ý nha, nếu em để tên của bạn nào trong đề tài thì cô sẽ tính điểm cho bạn đó và sẽ gọi bạn đó để thuyết trình. Cho nên là em chú ý là nếu như bạn nào hoàn toàn không làm thì không có tên thôi. Kệ bạn đó, thì cô chấm không điểm thôi.
Dạ.
Ừ. Trần Nhật Cường, tên xuất hiện hai nhóm hả? Sao bây giờ mới báo? Cô đã kêu kiểm tra rất là nhiều lần mà. Nhóm mấy về em? Thì em nhắn qua cô đi, em nhóm mấy? Em đang làm với nhóm mấy thì để cô bổ sung. Ý là cô nói là cái này cô thông báo là cô kêu em kiểm tra thông tin rất là lâu rồi mà sao giờ bây giờ mới báo? Em nhắn vô đi nhóm mấy thì để cô bổ sung, cô bỏ cái nhóm còn lại thôi. Mình đang CC02 đúng không? Một cái nữa cô nói các bạn là các bạn có thể là các bạn nhận email là học bù đúng không? Lúc lần trước cô cũng có định là học bù cho lớp các em thêm là thứ bảy là ngày mai, nhưng mà cô phát hiện ra là mình nghỉ lễ đúng không? Thôi để cô đã hủy cái đăng ký cái buổi bù đó nha. Các bạn cứ nghỉ lễ đi rồi tuần tới cô sẽ bù lại sau. Tại lớp mình không có thiếu giờ mà cô định là bù trước để cho các bạn có một tuần ôn tập thi thôi. Bởi vì lớp các em á là lịch của mình là chiều thứ sáu, nhưng mà học xong 5 tuần, thứ sáu học xong là chủ nhật thi luôn, mình sẽ không có một cái chút xíu giờ trống nào để cho các bạn ôn hết. Cho nên là từ đây đến đó cô sẽ sắp xếp bù và bù thêm một tuần để cô sẽ hủy cái tuần cuối cùng để cho các bạn có thời gian ôn tập rồi. Cho nên tóm lại là ngày mai mình không có học bù, các bạn cứ nghỉ lễ vui vẻ. Sao đúng không? Ok. Rồi 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 coi chút xíu. CC02. À, là em đang làm với nhóm 6, em bỏ tên ở trong nhóm 7 đúng không? Nhóm 6. À, tên em là gì? Trần Nhất Cường. Rồi cô bỏ nhóm 7 nha. Rồi lát nữa cuối giờ thì cô sẽ nói thêm một chút xíu về bài tập lớn. Và đồng thời các bạn chuẩn bị câu hỏi, ai có câu hỏi gì thì có thể hỏi thêm vào cuối giờ ha. Vậy bây giờ các em giải lao đến 4 giờ mình quay trở lại. Okay, now let's return to the board. Now we start with the first cases. Case 1. Suppose that the population follow normal distribution with parameter mu and sigma square. And in the first case, we assume that the variance sigma square is null. It's already given. Okay. Now because our parameter mu is unknown, it's unknown, so we want to make the test on parameter mu. Okay. Let's consider the hypothesis at 0. Mu equals to the constant mu 0. And h1 mu different to mu 0. Okay. The other cases you can try to you can try to do by yourself. It will be similar. Okay. Now I only consider the case of two-sided. The question is that firstly we assume h0 is true. Assume h0 is true. Assume h0 is true. Hence, assume h0 is true. Hence, we want to know when will we reject h0. When will we reject h0? Okay. Okay. Construct the hypothesis testing equivalent to answer for the questions. When will we should reject h0? We're looking for the criteria can tell us when we reject h0 and when we won't reject h0. Okay. Okay. Now, because the population mean mu is unknown, what we have is we just have the random sample. We have the random sample S1, S2, Sn is a random sample. Is a random sample. It's a random sample. So if S1, S2, Sn is a random sample, as we have learned, it must verify two conditions. The first one is Si are independent. Independent. Okay. And secondly, each of Si must follow normal distribution with the mean mu and sigma square. Okay. The random sample means that the given n observations must be chosen randomly from the same population. The same population is mean that each of them is a random variable with the same distribution. Okay. Here because we are assuming the population follow normal distribution. So equivalent to say that each of Si also follow normal distribution. Okay. So we already have the random sample. Of course, we're able to find the estimate of the parameter mu. The estimate of the population mean is given by S bar equals to S1 plus until Sn over n. Now suppose that okay, let's consider the example that I want to know whether the average height of students in our university is greater than 158 centimeter or less than 158 centimeter. Okay, this is the question about hypothesis testing. Because actually I can't observe the height of every student in our university. The population now will be every student in our university. And the average height here, this is the true average. the average of every student in our university. So in this case, I consider the hypothesis. The true average of every student in our university will be the, the population mean, mu equals to, I consider 158. And then H1, we consider mu less than 158. Okay. So what I need to do is not I randomly choose some student in our university. Suppose that I consider the sample of 100 students in our university. And from the sample of 100 students in our university, I have the average height. Suppose that I observe the average height of the given 100 students is 158.1 centimeter. So you may think that, okay, 158.1 is very close to 158. So we won't reach as 0. We can have the confidence to say that, okay, the average height, okay, the average height of students in our university equals to 158. Okay. But remember that the sample average is depending on the sample data. The first time I collect 100 students, I get H bar equals to 158.1. You have the feeling that we won't reach just as 0. But suppose not in the second case, I also collect a random sample of maybe 200 students in our university. And then I get H bar equals to only 155, for example. In this case, you see that 155 is far from 158. So you may have the feeling that, okay, we should reject as 0 because you can see that the sample average is so different to 158. So intuitively, I want to say that H bar is the sample average. The sample average representing the estimate for the true population average. But remember that the sample mean will be different by sample to sample. So 158.1 is close to 158. How can we know it's close? How much is close? And how could we know that 155 is far from 158? How much is far? All right. We need to know where how much is close or how much is far between H bar and the constant, such that we're able to reject as 0 or won't reject as 0. Okay. So return to our constructions. Assume that S0 is true. Then we need to answer for the question, when will we should reject S0? And as I already showed you that, we will basing on the point estimate of parameter mu, which is H bar. We measure we reject S0. We reject S0 if the distance between H bar minus mu 0 as far as possible, right? If the differences between the sample mean and the given constant is as far as possible, we have more confidence to reject S0. Okay, as far as possible, so I write out the absolute value between H bar minus mu indicates the distance between H bar and a constant greater than the constant C, where C is the possible constant. If C is If C is big, if C is bigger, imply that there are much differences between H bar and mu zero. So we have stronger evidence. So we have stronger confidence to say that we reject I zero. And oppositely, if C is small, it means that the distance, the differences between H bar and mu zero is small. So we have less confidence to say that we reject I zero, right? So the constant C is the critical value. Is it the critical value measure how much differences between H bar and mu that allow us to make the conclusion on H zero. Okay. So the question is now we need to find the constancy because the constancy can tell us the conclusion of H zero. Of course, we need to find the constancy. How to find the constancy? Theoretically, we want that C is as much as possible, but we need some we need some limitations. Otherwise, how can we find C? Right? And here we will find the constancy basing on the fact that the probability of rejecting S0. The probability of rejecting S0 equals to the probability of absolute value of S bar minus mu 0 greater than the constancy equals to alpha. The probability of rejecting S0 must exactly equals to alpha. Okay. Now you can see that the given equation is the probability of the random sample S bar. The random sample S bar. Okay. So of course we need to know distribution of S bar. If we don't know distribution of the random variable, how can we find the probability? Right. So now return to S bar. What is distribution of S bar, everyone? Do you remember? Given assumptions about SI, SIs are independent and SI follow normal distributions. Hence, what is distribution of S bar? We did it so many times. Everyone. Normal, but what is the mean and the variance? We know that actually S bar is just the sum of n independent normal distributions. So of course it still follow normal distribution. It still follow normal distribution. The mean is what are the mean and the variances of S bar? Yes. S bar follow normal distribution with the mean mu and the variance sigma square over n. Okay, very good. So we already know distribution of S bar. Of course, we're able to find the probability given here. Okay, so first of all, I overcome the absolute value to be convenient. Okay, so I have S bar greater than C plus mu 0 or S bar less than minus C plus mu 0 equals to alpha. And let this is equation 1. Okay. We already know distribution of H bar. And we already give we know that distribution of H bar. Now calculating the probability of H bar where H bar follow normal distribution. So we did this so many times. The first step, we standardize the normal distribution to get the standard score, right? So we have probability of H bar minus its expected value, we have mu, over its standard deviation, sigma square root of n, greater than. Now remember that initially assume S0 is true. If S0 is true, it means that we are assuming mu equals to mu 0. Hence, I rewrite mu 0. Okay. And the right side, c plus mu 0, we consider minus mu 0 over sigma square root of n. Hence, we only have c over sigma square root of n. Or s bar minus mu 0 over sigma square root of n. Less than minus c over sigma square root of n equals to alpha. Okay. Now let z equals to s bar minus mu 0 over sigma square root of n. It follows standard score 0 and 1. Okay. And we rewrite the given probability. We have probability of z greater than c over sigma square root of n, or z less than minus c over sigma square root of n equals to alpha. Okay. Now, let's follow standard score. Remember that we want to, let this see equation 2. We want to looking for the constancy. Okay. And basing on the fact that, let's follow standard score. Okay. The density function of the standard score 0 and 1 is symmetric around 0. So here, I have the constant c over sigma square root of n. Oppositely, I have the constant minus c over sigma square root of n. Okay. Remember that because it is symmetric around 0, hence we have the upper regions area equals to the lower area. Moreover, the probability here is exactly equals to alpha, or imply that's plus. It means that the left area equals to the right area, and the sum of them must equals to alpha. So of course, here we must have alpha over 2 and alpha over 2. Okay. So look at the figure. Can you recognize what is the value of c written here? What is the value of c? Oh, sorry, what is the value of c over sigma square root of n? Look at the figure. What is the value c over sigma square root of n? Is equal to Anyone else? Can you recognize what is the constant c over sigma square root of n? Look at the figure. Anyone else? At the position such that the probability that z greater than this value exactly equals to alpha over 2. Basing on the definition, we have this is z alpha over 2. This is the upper 100 alpha over 2 percentile of the standard score. The upper 100 alpha over 2 percentile of the standard score. It will be the positions. It will be the value of z such that the probability of z greater than this value, or equivalently, the regions under the density functions and greater than this value, the error equals the error here is not equal to alpha over 2. Hence, corresponding to the position z alpha over 2. And z alpha over 2 is just the constant you're able to look up from the table of standard score, right? Given alpha, you look up z alpha over 2 basing on the table of standard score. Okay, hence until here, we can find z over sigma square root of n equals to z alpha over 2. Sigma already given, n is the sample size, and z alpha over 2 look up from the table of standard score. Of course, you can find the constancy. So return to the beginning. We told that the constancy is the critical value can tell us when we should reach at 0. So actually, we already done. We already found the constancy. Hence, we already done. We can know when we reach at 0. Okay. But I want to make a little bit more step. Because we, as we know in the general procedure, two important steps to construct the hypothesis testing. The first step is identify the test statistic. Second step is the third step, we identify the rejected regions. Okay, even though until here we already found the constancy. Now we plug in again the constancy into equation 2, and we identify the test statistic and the rejected regions. Okay. So what is the definitions of the test statistic? We said that the test statistic will be the quantity calculated from the sample data, and it can tell us when will we reach at 0. Okay. So first of all, I plug in the term c over sigma square root of n into equation 2. So I get probability of z greater than z alpha over 2, or z less than minus z alpha over 2 equals to alpha. I write down one more step. The probability of z belong to the interval from minus infinity to minus z alpha over 2. Union with, so this is union with z alpha over 2 to infinity equals to alpha. Okay. I write down it as the interval, the real interval, because rejected region is the real interval. Okay. So now let I remind you the definitions of the rejected regions. It said that the probability of the test statistic belong to the rejected regions is not equal to alpha. So now comparing equation star and the definitions, can you recognize? The test statistic belong to rejected regions is not equal to alpha. So from the last equations, we can identify that the test statistic equals to z equals to h bar minus mu 0 over sigma square root of n. I identify that the value of z is the test statistic value because this quantity can be calculated totally based on the sample data. S bar is the sample mean. Of course, you calculate it from the sample data. Mu 0 is given, sigma is given, and n is given. Hence, the value set verifies the test statistic value. Okay, and then the rejected regions equals to minus infinity to minus z alpha over 2, union with z alpha over 2 to infinity. Okay, so we have done the procedure. If you plug in the data, calculating the test statistics z If it belongs to the rejected regions, we confirm reject as 0. Otherwise, we confirm that we won't reject as 0. Okay, so we have done the procedure in the first case. Remember that the first case, we need very important assumptions. The first one is normality assumptions. The population follow normal distributions. And secondly, the variance must be given. Okay, so now I let the extension question for you. How about how about sigma is a no. Sigma square is a no. How about sigma is a no? In case not, the variance already given. So in the last step, you can see that I recognize not that the value calculated from Z is the test statistic values because sigma already given. All of the given term, I can identify it only basing on the sample data. Now, of course, when sigma is unknown, if sigma is unknown, the value of Z can't be the test statistic anymore because parameter as sigma square is unknown. We don't have this value. Okay. And sigma already given. If we consider the null hypothesis mu equals to mu 0, we already found the test statistic Z0 equals to S bar minus mu 0 over sigma square root of n. And we know that the test statistic follow the test statistic set follow the standard score 0 and 1. If the test statistic follow the standard score 0 and 1, the critical value basing on the standard score sets alpha over 2. This is the case we have done on the plot. For other case, in case of one-sided alternative hypothesis, you try to repeat the procedure by yourself. Okay, repeat the procedure by yourself and make conclusions for the rejected regions. It helps you to better understand. Okay, remember that you should repeat the procedure by yourself to be understand better the theory. So because the test statistic follows standard score, hence we said that we have Z test. So Z test it just means that we basing on the standard score to make the decisions. Okay, and the table for Z test always the same. It's depending only on significant level alpha. Okay. The next case, as I told you, we need to extend the procedure in case that the variance is unknown. In case the variance is unknown, if you repeat the procedure, you see that because sigma is unknown, so naturally we choose the sample standard deviation S to approximate for sigma. S approximate for sigma. So on the way, we standardize normal random variable S bar. We use H instead of sigma, hence we have student distribution instead of standard score anymore. Okay. Now in this case, the test statistic follows student distribution. We said that we have t-test. T-test it just means that the critical value is identified basing on the student distribution. And in this case, t-test, the table for t-test, depending on degree of freedom. In this case, the degree of freedom is n-1. Okay, then you identify the rejected regions basing on Tn-1 alpha with 2 or alpha if you're working with one-sided. Okay. So in the first two cases, we need two important assumptions. We need important assumption, that is the population must follow normal distribution. Now let's consider the next case. Suppose that we don't have normality assumptions. We don't know whether the population follow normal distribution or not. Generally, we don't have information about the population, or the population can follow any of the distributions, but not normal distribution. Okay. In this case, we need the large sample size. If we have the large sample size, Hence, remember that Z equals to h bar minus mu 0 over sigma square root of n. Now, even though we don't know distribution of h bar, but the central limit theorem said that if we don't know distribution of the population, but we want to estimate for the distribution of the sample mean h bar. Hence, the central limit theorem say that if the sample size is enough large, then Z follows standard score, approximately follows standard score. Okay. Now, suppose that sigma already given. Hence, the test statistics Z0 given as in the first case, because it's approximately follow the standard score by using central limit theorem. We know that we use Z test, and the table for Z test is always the same. Even though if sigma is unknown, we replace sigma by h. But because we need the sample size is large, hence the differences between h and sigma is not much differences. And approximately, the test statistics still follow normal distribution. It's approximately follow normal distribution, hence we still use that test. Okay. Once more time, my advice is that even though I only show you the constructions for the first case, you try to repeat the procedure by yourself. You try to reconstruct the hypothesis testing for the second case and the third case. If you can repeat the procedure by yourself, so you can understand well the theory. Okay. Anyway, until now we learned together 3 hypothesis testing for the population mean, and 2 of them using z-test, and only 1 of them using t-test. We only use t-test in case that the population follow normal distributions and the variance is unknown. Okay. Okay, now I would like to return to the board and we try to do some example together. Okay. Okay. Now please have a look on example 4. Focus on example 4. Firstly, let you a few minutes you try to summarize the information by yourself. Then we return to finish this example together. Okay. Few minutes for you. Okay, now return to example 4. First of all, I would like you to summarize the information with me. Okay, now look at example 4. Tell me what is the sample size n? N equals to everyone follow my follow for follow me during the exercise. Okay, look at the first sentence. We see that in a random sample of 20 components, so easily we have n equals now look at example 20. 4. Now can you please tell me what is the value 100h.6? 100h.6. What is the value of 100h.6? Is this h bar or is this mu? It said that the mean length of each component is 100h.6. So should I write h bar or mu? Everyone? We are all the students. Okay, we recognize that it's the h bar because this is the sample mean. The mean length of components in the given 20 components. Okay, given 20 components. And similarly, 6.3, this is the sample standard deviation or the population standard deviation. The sample standard deviations or the population standard deviation, everyone. The sample standard deviation. So should I write S or should I write sigma? S or sigma? Everyone. Please follow me and show me your answer in the chat box. I'm guiding you step by step. Yes, this is the sample standard deviation denoted by S. Okay. And then we have 5% level of significance. So alpha equals to 0.05. Okay. Now I need the null hypothesis H0 and the alternative hypothesis H1. Tell me how to write the null hypothesis H0 and the alternative hypothesis H1 in this case. Everyone, it's your turn. Please show me the null hypothesis and the alternative hypothesis in this case. This is the prior step for every hypothesis testing. First step, summarize the information. Second step, write down the hypothesis. I'm waiting to have more answer from you. I'm waiting for your answer. Okay, very good. We have H0 given by the first step, identify the parameter we want to test. Okay, read the last sentence. Is there enough statistical evidence to show that the production line is producing components that are of an incorrect length. Incorrect length. So what does it mean? If the line producing incorrect length, if the mean if the mean length of components different to 105 millimeters. Okay, so we know that we care about the mean length, the mean, the population mean given by the parameter mu. And as I told you, to write the null hypothesis, you just need to care the parameter we want to use, and then put equality, and then the constant we want to compare. The constant here, 105. Okay, and then the alternative hypothesis. We need to know we should use two-sided or one-sided. In this case, we only care whether the line is producing correctly or incorrectly. Okay, we only care incorrectly or correctly, equivalent to compared to 155. We only care equal or not equal. We don't care greater than 105 or less than 105 millimeters. We only care different or not. Hence, this is two-sided. That's all. Okay. Now, we have the assumption that the population distribution is normal. So I write, if I indicate S is the length of components, the length of components. Okay. Hence, we have the assumption that S bar follow normal distribution with the mean H mu and the variance sigma square. Okay. In this case, we already given very important assumption. That's a normality. Now, should we use equal or unequal variance? Oh, sorry. Should we have the case of given variance or unknown variances? Everyone. No or unknown variance. Anyone else? Very good. Unknown variances. Because in this case, we're not given any information about sigma square. We're only given the sample. We only given the sample standard deviation S. We're not given sigma. So this is the case of unknown variance, unknown sigma. So should we use Z test or we use T test? Very good. We should use T test. Okay. Normality and unknown variance. So we use T test. If we use T test, so we know that the test statistic, the test statistic the test statistic T0 equals to S bar minus mu 0 over S square root of n. S bar we have 108.6 minus mu 0 is 1, 0, and 5 over S is 6.3. Square root of n is 20. Okay, now please use your calculator and tell me the value of T0. T0 is 256. Okay, thank you. Oh, no. That's 5, 5, 5, and 5. Okay. So now we know that we should use t-test. Using t-test, so the critical value is given by t n minus 1 alpha or alpha over 2. Should I use alpha or alpha over 2? In this case, Anyone else? Should we use alpha, Tn minus 1 alpha or Tn minus 1 alpha over 2? Alpha over 2. Because we consider two-sided alternative hypothesis. Two-sided, so use alpha over 2. Okay. So we need Tn minus 1, we have 19 degrees of freedom. Alpha over 2, we have 0, 0, 25. Okay. Now using the table of t-test, using the table of student distribution. Table of student distribution. Okay, we're looking for student distributions. Okay, and we need we need student distribution with 19 degree of freedom, T19, and the probability 0, 0, 25. So degree of freedom in student distribution table given by the first column. The first column, we have 19. The probability corresponding to the label in the first row, I have 0, 0, 25. So we have 2, 0, 93. So we have, I return to the board. We have 2, 0, 93. Okay. Hence we get the rejected regions. The rejected regions equal to R and R. That is the interval from two-sided. So the left side is minus infinity to minus the critical value. Union with 2, 0, 93 to infinity. Okay. Now, because the test statistic T0 belong to the rejected regions. It belongs to rejected regions. Hence, we confirm that S0 is rejected. Okay, S0 is rejected. We need to confirm the final. We must take the final conclusions for the given questions. S0 is rejected imply that we have enough evidence. We have enough evidence to confirm that the lie is producing components of an incorrect length. Okay, remember that once you already confirm S0 is rejected or not, you need to answer for the given questions, because the aim is that you want to answer for the given questions. Hence, if S0 is true, we confirm that we have evidence to confirm that H1 is true. H1 is true in this case imply that the lie is producing incorrectly. In case that S0 is not rejected, we confirm that we don't have enough evidence. Okay. Any questions, everyone? Okay. So return to the slides. We continue with the last cases. The last cases. Now we're interested on the population proportion. Let's P is the proportion of event A in a population. For example, I may interesting on percentage of students in our university who has the height greater than 158 centimeter, for example. Okay. In this case, the proportion of event A in population is a no parameter. Because except I can make a survey for every student in our university, then I can know percentage of students who greater than 158 centimeter of the height. But actually, I don't. Actually, um I can't make the survey for every student in our university. So this proportion is a no. It's a no parameter. Okay. And in reality, I only have the random sample of some student in our university. And what I need to do is that I I ask them about the age of the age of each student. Student one, if it's greater than 158, I indicate it by one. If no, if less than 158, I indicate it by zero. So in this case, we also have the random sample of size n, and each random variable yi only receive two values 1 or 0. 1 if the observation I is showing event A, and otherwise I indicate by 0. It just means that I count the number. I count the number of our interesting event, showing our interesting event. I count how many students in the group, in the sample of 100 students who greater than 158. So yes, I indicate by 1, 0 I indicate by, if no, I indicate by 0. 1 and 0, 1 and 0. Student 1 until student 100 in the sample. And I take the sum. Of course, it indicates the number of our interesting events. The number of our interesting events over the sample of n observations. In this case, s equals to y1, y2 until yn. Okay, and each of yi follow Bernoulli trial, and s follow the binomial distribution with parameters n and p. Okay, so as we did together in the first three cases, the first step we need to identify a point estimate for the given parameter. Now we want to estimate for the proportion of the population p, and what we have is just the random sample. Of course, a natural choice to estimate for the population proportion is the sample proportion p hat. P hat defined as s over n. It just means that we count among n observations how many of them showing our interesting event. Take the total number of events over by the sample size. We have the sample proportions. Okay. And the next step, as we have done in the first three cases, the next statistic is obtained by standardizing the point estimator. Okay. We standardizing the point estimator. So in this case, to standardize the point estimator p hat, I need to know the expected value of n and the variance. Okay. Now I have e of p hat. E of p hat equals to e of s over n equals to e of s over n. Because we know that s follows binomial distribution. So expected value of binomial distribution equals to np and then over n. Hence, we have p hat, e of p hat equals to p. Okay. Similarly, the variance of p hat equals to the variance of s over n squared. Remember that 1 over n is the constant. I take it outside, so I have n squared equals to the variance of binomial random variable. We have n p 1 minus p over n squared. So finally, we have the variance So finally, we have E of pH equals to P. And the variance of pH equals to P1 minus P over N. Okay. Now, as we have done, to looking for the test statistic, we standardize the point estimate. Let Z equals to standardizing any random variable. We consider this random variable minus its expected value pH over its standard deviation, square root of the variance pH. Okay. But now, what is distribution of Z? The first case is we know that we should use Z test because the test statistic Z in on the way we standardize S bar follow standard score. In the second case, we know that we should use t-test because the test statistic t follow student distribution. So now, if we standardize pH, what is distribution of p? What is distribution of z? We don't know because we don't know distribution of pH. Distribution of pH is depending on distribution of s. S follow the binomial distribution and then over by n. It's not follow normal distribution. And as we have learned together, in case that we don't have normal distribution, but we want to approximate the random variable by using normal distribution, we think about using the central limit theorem. But the central limit theorem states that, let I remind you, central limit theorem states that if the population follow normal distribution and we have the random sample S1, S2 until Sn, then we define Z equals to the sample mean S bar minus its expected value over its standard deviation V of S bar. It's approximately follow standard score 0 and 1. The central limit theorem states for the sample mean. If we have the case of S bar minus E of S bar over square root of the variance S bar, then using the central limit theorem, it approximately follows standard score. But now we have Z equals to pH minus E of pH over square root of the variance pH. It's not the sample. We're working with the sample proportion, not the sample mean. So how can we use the central limit theorem in this case? Right? So of course you think the link. There is a link between pH and the sample mean. We need the sample mean if we want to use the central limit theorem here. Okay. So remember that pH defined as h over n. Moreover, h equals to the sum of yi over n. The sum of yi over n, hence we have y bar. Here. The key is that pH equals to y bar. Y bar is the sample mean. The sample mean of y1, y2 until yn. So once more time, even we're working with the population proportion, but it still return to the sample mean. It's similar as the first three cases. Okay. Hence now, Z equals to pH minus E of pH over square root of pH. And pH actually equals to y bar. Hence, using the central limit theorem, it approximately follows standard score 0 and 1. Okay. Now I rewrite. Z equals to pH minus its expected value is P. But basing on the fact that S0 is assumed to be true, P equals to P0. So I plug in P0 over square root of the variance we found here. The variance of pH is P1 minus P over N. And P equals to P0. So we plug in P equals to P0. We have P0, 1 minus P0 over N. There, we identify that this is the test statistic because all of the term can be calculated from the sample data. Okay. Moreover, it follow normal distribution, approximately follow normal distribution. So once more time, we use z-test. Using z-test, it just means that the test statistic follow the normal distribution, the standard normal distribution. Okay. And the table for z-test, once more time, it's always the same in any situation. It's just depending on the significant level alpha. That's all. Okay. Now let's practice on the last case. Example 6. Okay, now return to the board. Try to focus on example 6. Summarize the information and write down the null hypothesis and the alternative hypothesis by yourself. Okay, few minutes for you. Okay, example 6. Now we care about the proportion of portals that are contaminated in this way. Contaminated in this way is mean that uh, it is exploited for some extent by the core associated characteristic. Okay, this is contaminated in relating to the cock. Okay, and we care about the proportions or percentage of, sorry, we care about the proportions or percentage of portals. So we know that we are working with the parameter p. P indicates percentage or indicates the true population proportions. Okay, so we can write down easily p equals to a constant. Here we care about the constant is 0.15. And in this case, very clearly that we use one-sided. So one-sided alternative hypothesis, we write p greater than 0.15. Okay, and summarize the information. Okay, tell me what is the value 16 and the value 91 in this case? What is the value 16 in these questions? Which notation I should write here? Look at the second sentence. An article reported that in a stating of commercial coordinates, 16 of 91 bottles were considered poised to some extent by core associated characteristics. So what is the value 6 and what is the value 19 in this case? For one. Very good. 16 is as indicates the number of our interesting events in the sample of n elements. In the sample of n elements. Hence, if we have s and n, we can have p hat equals to s over n equals to 16 over 91. Okay, so because during the course we only study one cases for testing proportions of population, and we know that we use the test. We use that test. We only have one cases, so we don't need to confuse. If you have the questions about proportions testing, so we only have one cases. That is using Z test. Nothing to be worried. So now, using Z test, we need the test statistic. Z0 equals to p hat minus p0 over square root of p0 1 minus p0 over n equals to p hat. We have p hat is 16 over 91 minus p0. P0 is 0.15. Square root of p0, we have 0.15, 0.85, and over n. N is 91. Okay, now please use your calculator. What is the value of Z0? Z0 equals to Z0 equals to anyone else who has done 0, 6, age 99. Okay, thank you. And using Z test, hence in this case we use Z alpha over 2 or Z alpha over 2 or Z alpha. Using alpha because we we only consider one-sided alternative hypothesis. Hence, we should use alpha instead of alpha over 2. So Z alpha equals to Z of alpha is 0, 0, 5. Okay. So we have Z 0, 0, 5. So equals to, using the table standard score, what is the value Z 0, 0, 5? Z 0, 0, 5 equals to, who has done? 164, 258, which one? 165. I think that 165. Okay, anyway, you try to check it using the table standard score. Okay. Okay, hence, we confirm that the rejected regions is R and R equals to, we care about P greater than P0. Hence, we want that we reject S0 if pH is we care if the distance is as large as possible. So we have if the test statistic is as large as possible, so the critical value to infinity as large as possible. Okay. In this case, we see that Z0 equals to 0, 60, 0, 6H, 99. It doesn't belong to rejected regions. So doesn't belong to rejected regions. Hence, we confirm that S0 is not rejected. If S0 is not rejected, we confirm that there is not enough evidence. Not enough evidence. There is not enough evidence to confirm that. The proportions are protons, which is contaminated. In this way, is greater than 15%. That's all. Okay, we have done. Any questions, everyone? Okay. Okay, so it's also the end of chapter 5. Chapter 5 is a little bit short. Do you have any questions for our lessons? Okay. If you have no questions, so let's talk a little bit about the teamwork project. Okay. Okay, wait a little bit. It's too slowly. Okay. Okay, so as you have known that I already give you the list of proof and the list of and the corresponding topics. So until now, at least you should know your teammates. and you should know the topic you need to work. And actually, some students they told me that they already done the teamwork project, even though we haven't done the course. I told you this because I want to notify you that the deadline is coming very soon. Okay. Now click on the list of topic. Uh, I try to answer for some typical questions that I receive from students. Okay. Um, Firstly, you must strictly follow requirements. Okay. For example, the writing report must never exceed 30 pages. Okay. The accepted minimum or the accepted maximum of pages only 30, including the cover. Okay. And because you have 30 percentage for writing report, so you must strictly follow the requirements. You must have the writing skill because you only allowed to use 30 pages. So um, you need to determine which kind of information is important to put into the writing report. It's accounting to three cases to your total teamwork project. So writing also important. Okay. And nextly, I received the question that do you allow to use any other programming language? No, the answer is no. For this teamwork project, you must use R or R Studio. No more choice. Okay. And nextly, if you go down, each group is given one topic, and the given topic has two activities: activity one and activity two. In activity one, as you can see, the you already given the the data set. This is the real data set, and you also uh, you also given step by step how to deal with the data analysis in this situation. The aim of activity one, we want to show you the general framework to working with the real data analysis. Okay. For example, you can see step one, import data, step two, data cleaning, step three, data visualizations. Data visualizations, it means that it's the test, the descriptive statistic we have learned in chapter four. And then fitting the model and predictions and so on, for example. This is the typical framework for doing the data analysis. Okay. And I received the questions from your friend. In the data set, you have several variables. So should you include every variables in the data analysis, or you only choose some variable as given in the activity one? The answer is that you only need to include the given variables. You don't care about the other one. Okay. Nextly, usually I receive the question relating to activity two. Because activity two only give you very general questions. You need to find a data set which is close to your study measure, and then you are free to choose any method to do the data analysis. Okay. And I also received the question that you can see clicking on the data project, the data for the project. At the end, you have one Excel file. This is the collections of some real data sets. Okay. And they already classified into different departments. So you can choose to use the dataset given in these collections, or you are free to choose any other datasets. Even you can use the dataset you found from internet, or you can make the surveys by yourself, or you can use the or you can use the data set from the real experiments, the use experiments. Okay, so in activity 2, look at the bonus. Because you are free to choose any data set, so of course you need to advise me, you need to convince me. You need to convince me why did you choose the data set? Because the answer of the question is not you need to choose a data set which is close to your measure. Okay, so you need to show me why did you choose this data set, how it's close to your measure. And more meaningful data sets, more meaningful data set, you have better score. Okay, for example, I suggest that I prefer that you can choose a novel clinical or experimental data sets. The data sets come from the true experiments. I will refer then the data set using you got from the internet, for example. Okay. Anyway, the meaningful data set will give you more bonus. You have better score. Okay. And also the method. Of course, you are free to choose any method. You can free to choose any approach. But if the students can get a more complicated data set, more complicated approach, will better than the students who only apply very simple data set. For example, if you give me the data set and then you only use confidence interval to make the inference, and the other method, the other student, they can apply more complicated approach and they get more information. They get more conclusions from the data set. Then of course they have better score. Okay. And the most important is that you must understand well what you are doing. Because only 3 score for writing report, 7 score given during the oral sessions. Okay, so I want to check whether you understand well what you are doing. So I'm welcome for further discussions. I'm welcome for any further comments, significant comments. You have better score. Okay. Of course, if you written in the report very complicated, but when I ask you, you don't understand anything, so you have 0 score. If you understand a little bit, so you have a little bit score. That's all. Okay, because you have separated score for written and for oral. Okay, and nextly, the reference book. To have you deal with the teamwork project, you can see I uploaded 2 books, especially the second one. I think that the second book is very close to your teamwork project. If you go down, you will see that. Look at the contents. You see that each chapter here totally corresponding to each chapter we learned during the course. For example, you have the whole of descriptive statistics. In chapter 4, I tell you that descriptive statistics we don't learn during the course because we have very limited time. But it's the prior step to deal with data analysis. And here you have the whole chapter. It shows you how to use the figure, how to use the table to summarize the data, to represent the data. Okay. And then go down, you see that you have 1 and 2 sample hypothesis testing. It's corresponding to chapter 5 and chapter 6 we learned together. We just done together. Okay. And also there are some other methods. For example, here the rank test we don't study during the course, but you can have a look. And then the comparison of variances or and so on. You can try to have a look. and regressions corresponding to chapter 8 are ANOVA corresponding to chapter 7. And also you have the Kruger one listed. This is extension of ANOVA. Especially, you can see that you're not only given the theory, it's also give you the articles. They already give you the articles. So that's the reason why I think that this book is very useful for you. It gives you I summarize the theory according to each chapter we learn together in the course, and also you are given the corresponding articles. So if you have a good reading skill and a good uh, teamwork skill or teamwork skill, then you should done the project. You should done the project well. Okay. Okay. Try to have a look on this book. It's very useful. Okay. Now the last thing I want to say is the project evaluation. As you know that, look at the announcement too. The project evaluations include the team score and the quiz score. The quiz score you already know. This is the average score of the quiz given at the end of each chapter. Okay. We already have the quiz for chapter 1 to chapter 3. And in the next few weeks, you want to the score for the later chapters. The quiz score accounting to 10 percentage. It means that one score for the quiz and 9 score for the teamwork project for the team score. The team score plus or minus 0. What does it mean? At the end of the course, we will organize an oral sessions. Okay, and in this sessions, I ask every member in each group some questions relating to the project. Okay, not randomly choose some of you. Remember that every of you must answer my questions. Okay, and even though I evaluate for each student, but I only give you the average score. The average score is the team score. It's the same for every member. Okay, and after that, you must discuss with your teammates to decide the score for each member, because you understand well who contributes more than the other. Then, when I give you the team score, you discuss together. Of course, I need the agreements of every member in your group, and you return to me the score for each member, with the rule that the score for each member can't be different by 2 scores compared to the team score. And averagely, the score of every member must exactly equal to the team score I give you. Okay. For example, if I give you the team score equals to 7 score, then if one student get 9 score, then the other student must decrease maybe 7, maybe 8. Just that take averagely, the score still be 7. Okay. Once increasing the score for one student get increasing score, the other student must be decreased, such that the average always equals to the team score. Okay. And lastly, pay attention that if you absent in the presentation sessions or you be late more than 20 minutes, you get 0 score. You get 0 score for the oral sessions. You only get a maximum of 3 score for written report. Okay. So because if you absent, I can't give you the question, so how could I understand what you have done? Okay. So remember that never try to be not absent or not late more than 20 minutes in the final presentation sessions. Okay. It takes 7 score to your total score. So don't miss don't miss at the end. Okay. Anything else? No, that's all. So do you have any questions, everyone? Yes. questions.
I have a question about the presentation day.
Mm-hmm.
That if we each member of the team we represent about our report, or you just ask
No,
you just ask questions.
no, this is the oral. This is the oral test. So I just choose. I just give you some questions, and you answer my questions. That now, okay? And of course, you can share your screen about your written report, but not represent from beginning until the end. I just randomly choose some related questions, and you just simply answer my questions. That's all.
Yeah, I got it. Thank you.
Anyone else questions? And also for the dates of the presentations, I also give you some choice, and your group just choose a suitable day for you. Okay, so there is no reasons that you absent because you choose the day, you choose the you choose the schedule for your presentations. So try to be not absent. Okay. Anything else? And remember that we don't have any lessons for teamwork projects. For teamwork projects, so the teamwork projects you need to work with your teammates. And if you have any questions, so you can give me the question by email. But it's better if you directly ask me at the end of the lessons. Okay. For the teamwork projects, it requires you self-study and teamwork teamwork skill. And the teacher only support you during the procedure. Okay, we don't have any lessons. Now, as I tell you, you don't allow to use any other language, only R or R Studio. Okay, and the language is R, but you can use R um, um, to code, or you can use R Studio to uh, to uh, to um, to to work. Actually, R and R Studio use the same language. It's just different by um, it's just different by uh, R Studio is better for display. It's easier to um, it's easier to communicate. That's all. Anything else? Anything else? No? Okay, so finally, strictly follow the deadline. Okay. And close to the deadline, I will upload the link for submissions. Okay. Okay, if you have no more questions, so we can stop here and see. Okay, questions?
Cô cho em hỏi là cái kết quả kiểm tra hôm trước em bị lúc mình nộp bài nó bị trục trặc á, thì không biết là bây giờ không có sao mà em có gửi mail với lại gửi video record rồi.
Là sao em?
Có nghĩa là lúc em nộp bài nó bị trục trặc, phòng báo đề nó không có nhận được điểm của em á.
Nhưng mà cái vấn đề về thi giữa kỳ, thi midterm thì cô có feedback email lại rồi mà. Nếu như mà những bạn mà có nằm trong email thì có 4 bạn là thi lại, có 4 bạn là thi lại bởi vì vắng mặt vì lý do như là bị mất điện ngay cái lúc thi, hoặc là có là F0 hay gì đó. Nói chung là có 4 bạn thì thi lại bởi vì bạn hoàn toàn không có thi giữa kỳ. Có 4 bạn là phải thi lại, có 4 bạn là thi oral là bởi vì vấn đề về record. Còn nếu như em không có trong danh sách đó thì là bình thường, không có gì hết, vậy thôi.
Dạ, em cảm ơn cô.
Tại vì cô không nhớ, em có gửi email cô có feedback chưa, cô không nhớ nữa, tại vì vừa rồi cô cũng xử lý khá là nhiều email liên quan tới khá là nhiều thông tin liên quan tới midterm ấy, cho nên là cô cũng không nhớ chính xác có trường hợp của em không. Nhưng mà nếu như em có nằm trong danh sách đó thì em đã nhận được email rồi, thì nếu như em không thấy có feedback thì chắc là không có vấn đề gì thôi.
Dạ cô chứ không feedback ạ.
Không, vậy thì không có nằm trong danh sách phải thi lại. Còn nếu có vấn đề là cô đã gọi thi lại rồi. Có
Dạ,
4 bạn vừa rồi đã thi lại oral rồi, và có 4 bạn thì sắp tới thì make up. Còn nếu em không có trong danh sách thì không sao.
dạ, dạ.
Ừ. Okay, anything else? Okay, so see you next week. Okay, have a good holiday.